This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on Lagrange multipliers. Our goal is to find the minimum value of this function. F of xy is x squared plus 2y squared minus xy, subject to the constraint 2x plus y equals 22. And we're going to start by focusing on this constraint equation. We want to make that equal 0. So we're going to rewrite that as 2x plus y minus 22 is 0. This part, 2x plus y minus 22, becomes g of xy. So g of xy is our constraint equation equaling 0. So g of xy is 2x plus y minus 22. And then we construct this function capital F. Capital F is the original function little f plus lambda times this new function little g. So our little f function, x squared plus 2y squared minus xy, plus lambda times g, 2x plus y minus 22. This is our function capital F. Let's distribute the lambda, so it'll be 2 lambda x, lambda y minus 22 lambda. And this is the function we're working with in our method of Lagrange multipliers. And then we need to find all of the partial derivatives. We need to find f sub x, f sub y, and f sub lambda. So here's our strategy. Set f sub x equal to 0, set f sub y equal to 0, set f sub lambda equal to 0. We need to solve for x and y. You could solve for lambda, but it's not really relevant. Then we want to identify the maximum or minimum of that function and where those are located. So here is our function capital F that we determined earlier. We want big F sub x, so the partial with respect to x of x squared, partial of x of 2y squared, partial of x of xy, partial of x of 2 lambda x, partial of x of lambda y minus partial of x of 22 lambda. Now, if there's no lambdas, the result is 0. Excuse me, no x's, the result is 0. Partial of x of 2y squared gives me 0. Partial of x of lambda y gives me 0. Partial of x of 22 lambda gives me 0. This first piece, partial of x squared, of course, is just 2x, because all it is a function of x. There's the 0. Here, let's pull the y out in front, times the partial with respect to x of x. Let's pull the 2 lambda out, since that's perceived as a constant. 2 lambda partial of x plus 0, no x's, plus 0, no x's. Partial of x is just 1, partial of x is 1. So we get 2x plus 0 minus y times 1, plus 2 lambda times 1, plus 0 minus 0. So there's our partial derivative of capital F with respect to x. We're going to do the same thing for y and for lambda. So next up I need f sub y, the partial of y of the first piece, that'll be 0. Partial of y of the second piece, we're going to pull the 2 out in front. Partial of y of xy, we'll pull the x out in front. Partial of y of 2 lambda x will be 0. Partial of y of lambda y, we'll pull the lambda out in front. Partial of y of 22 lambda will be 0. Now this thing is 2y. That's 1 and that's 1 using the derivatives. So we're going to get 2 times 2y minus x times 1 plus lambda times 1. Big F sub y becomes 4y minus x plus lambda. And there's one more partial derivative for us to do, namely f sub lambda. So we take the partial with respect to lambda of all of these things. First piece is 0, second piece is 0, third piece is 0. Pull out 2x, pull out y, pull out 22. And these guys are all just 1. So 2x times 1, y times 1, 22 times 1. And we get f sub lambda is 2x plus y minus 22, which you will notice is the same as that function g of xy that we looked at earlier. Now we get to do some algebra. We have all three partial derivatives, set them equal to 0, and solve for x and y. So f sub x is 0, f sub y is 0, f sub lambda is 0. I like to solve for lambda in one of these first two, and I think this one will be simpler to solve for since this one has a 2 multiplying by lambda. I think I'm going to solve for the lambda in this middle equation. So adding negative 4y to both sides, adding x to both sides, I get negative 4y plus x is lambda. Then I'm going to substitute negative 4y plus x in for the lambda here. So we'll get 0 is 2x minus y plus 2 times negative 4y plus x. Doing the algebra, 2x minus y minus 8y plus 2x. 2x plus 2x is 4x. Negative y minus 8y minus 9y. So I have 0 equals 4x minus 9y. 9y is 4x. Y is 4x over 9. And that is going to get substituted in this third equation so I can solve for x. That will become 0 equals 2x plus 4x over 9 minus 22. 2x times 9 is 18x, 4x times 1 is 4x, 18x and 4x, 22x over 9 minus 22. Add 22 to both sides. Now I have to solve for x, multiply by the reciprocal. X is being multiplied by 22 ninths. Multiply by 9 22nds. The right-hand side becomes x, the left-hand side is just 9. So if I know x is 9, how do I find y? I plug the x is 9 into this equation. 2 times 9 plus y minus 22 is 0. 18 minus 22 plus y is 0. Y minus 4 is 0. Y is 4. So we found our optimal point. We have x is 9 and we have y is 4. That's the point we were looking for in our method of Lagrange multipliers. So we're told this is going to be a minimum value, and frankly, the Lagrange method does not tell us if it's a minimum or a maximum, so typically in this course, the question will make that clear. So we want the minimum value. We know that x is 9 and y is 4. Notice 2 times 9 is 18 plus 4 is 22. It satisfies the constraint equation. So I just have to plug 9 and 4 into this function f of xy. So f of xy is x squared plus 2y squared minus xy. So we get 9 squared plus 2 times 4 squared minus 9 times 4, which is 77. So that will be the minimum value of this function. The minimum value is 77 at the point 94. As long as we're concerned with this constraint equation, 2x plus y equals 22. Let's look at one more question. Find the maximum and minimum value. So we'll have to test our various points of f of xy equals xy subject to the constraint x squared plus y squared equals 8. So our first step is to rewrite this as x squared plus y squared minus 8 is 0. And that'll be our function g of xy. So g of xy will be x squared plus y squared minus 8. Then we construct that function capital F, which is little f plus lambda times little g. Little f is here, xy, plus lambda times little g, lambda times x squared plus y squared minus 8. Distributing the lambda, lambda x squared plus lambda y squared minus 8 lambda. And then our strategy is to find all the partial derivatives. First f sub x, which will be what? Let's see, we pull the y out, we pull the lambda out. This will be 0, this will be 0. This is 1, this is 2x, so y times 1, lambda times 2x. And we get f sub x is y plus 2 lambda x. We do the same thing for the partial of f with respect to y. Partial of y, partial of y, partial of y, partial of y. Pull the x out, this will be 0. Pull the lambda out, this will be 0. So this is 1, so x times 1, lambda times 2y. So we get f sub y is x plus 2 lambda y. And then we do the same thing for f sub lambda. We take the partial with respect to lambda of all these pieces. The first one's going to be 0, and the next are going to require us to pull some things out. So again, first piece is 0, pull out x squared, pull out y squared, pull out 8. This is 1, this is 1, this is 1. So x squared times 1, y squared times 1, minus 8. And we're going to set that equal to 0. Recognize that is our function g of xy that we established earlier in the problem. So we have all these first order partials, set them equal to 0. So y plus 2 lambda x is 0, x plus 2 lambda y is 0, x squared plus y squared minus 8 is 0. Always start with these two. I want to solve for lambda typically. So I've chosen to work off this one. Negative y is 2 lambda x, divide by 2x. Negative y over 2x is lambda. And then plug that in for the lambda over on this side. So we get 0 is x plus 2 times negative y over 2x, that's lambda times y. Now the 2's divide out, negative y times y, negative y squared over x. So we get 0 is x minus y squared over x. Add y squared over x to both sides, multiply both sides by x, and you will see that y squared is x squared. Well, if that's the case, I can replace this y squared with x squared. That will become 0 is x squared plus x squared minus 8. So 0 is 8 is 2x squared, 4 is x squared, which means X could be either 2 or negative 2. We have two possibilities here. Now I need to go through and solve for y. So I'm going to go back to this equation. 0 is x squared plus y squared minus 8. I know x squared is 4, so it'll be 0 is 4 plus y squared minus 8. 4 minus 8, of course, is negative 4, so 0 is y squared minus 4. 4 is y squared. So y is 2 or y is negative 2. How many different points of interest do we have? X is 2, y is 2. X is 2, y is negative 2. X is negative 2, y is 2. X is negative 2, y is negative 2. 4 different points for us to test. And we'll determine which ones yield the max and which ones yield the minimum. So we're going to plug all those points into this function xy. Notice in each case x squared plus y squared is 8. For all 4 of my points, the constraint equation is satisfied. 2 times 2 is 4. That's xy. Negative 2 times 2 is negative 4. 2 times negative 2 is negative 4. Negative 2 times negative 2 is positive 4. So you'll notice the maximum value has to be 4. So the function achieves a max of 4 at 2, 2, and negative 2, negative 2. And it achieves a minimum of negative 4 at negative 2, 2, 2, negative 2. So there's the max of 4 at 2, 2, negative 2, negative 2, and the min of negative 4 at the point negative 2, 2, 2, negative 2. And that will conclude this lesson.